Okay, so in this lesson, what we're going to look at are what are known as gamma rays. So, gamma rays. So, gamma rays are high energy electromagnetic radiation. So, electromagnetic radiation with greater penetration ability than beta particles. Okay, so it's a form of electromagnetic radiation, same thing as visible light, for example, but it's just much more energetic and it has a really high ability to penetrate through material. So, like just thinking of that, like if we have a look here at these, so alpha particles we can see here, um, like it doesn't take a lot to stop those alpha particles. So even a sheet of paper or even the surface of your skin will stop alpha particles. Beta particles are a little bit more penetrating. They'll easily pass through, for example, your skin or pass through a sheet of paper, but they will be stopped by 50 millimeters of aluminium, of elemental aluminium material. Now, if we take gamma rays, then gamma rays are very, very highly penetrating, and they will literally just pass straight through your body. They'll also pass straight through aluminium, and it actually takes like thick lead or concrete um, to stop these gamma rays from passing through. And this can be a major problem when it comes to storing nuclear waste that is still radioactive and still emitting gamma rays. Some of the half-lives, for example, on radioactive materials that produce gamma rays, can be up in thousands of years. And the problem then is to try and keep the waste material contained within suitable containers that will stop these gamma rays from getting out and damaging anybody in the locality. Again, gamma rays, when they come into contact with the human body, they cause problems, and they're also linked to cancer as well. They can cause cancer in the body. Ironically, as well, gamma rays can be used. So, for example, cobalt 60 can be used as a form of radio or radiation treatment to treat cancers. They can use a radioactive source such as cobalt that will give off these gamma rays, and they can use it to kill cancerous cells. And it can form the basis of therapy that uses radiation to kill cells, to kill cancerous cells or tumours. So this here, like what we're looking at here, is the nucleus of an atom. So again, gamma rays, like this radiation, it actually comes from the nucleus of the atoms. So where the nucleus is unstable, what it does is it gives off energy, and that energy is given off spontaneously, and that's what radiation is all about. So gamma rays they're just these high energy electromagnetic radiation, basically, that's really, really highly penetrating. So we can see here, so the red little spheres here are what are known as protons, and green spheres here are what are known as neutrons, and they form the subatomic particles that make up the nucleus of an atom. Now bear in mind, something like this, the nucleus of an atom is extremely, extremely small. Like if you were to take this dot that I've just put here on the screen, within that dot you could have more atoms. There'll be more atoms in that dot than there are, for example, grains of sand on all of the beaches on the entire planet. So that will give you kind of put into perspective how small atoms are, and how small these nuclei then are, even a smaller part of a small atom as it is. So if we take an example of gamma ray, or a radioactive material that gives off gamma rays, would be a substance that's known as cobalt 60. So cobalt 60. Cobalt 60 is an isotope of cobalt, and it can be used um, to emit these gamma rays, and that those gamma rays can be used to treat cancers, and they can also be used to uh, irradiate food as well and kill microbes on the food that would otherwise cause the food to spoil. So if we think about like the reaction then of this, so the equation, this is what it would look like. So CO, that's the chemical symbol for cobalt, We put this number at the top of 60, which is the mass number. So it's cobalt 60. So 60 represents the mass. The mass is made up of the protons and the neutrons that are present. And then we have 27 here. So this is the atomic number. Okay, and then this is the mass number. So the atomic number is the number of protons that are present. So it's the number of these guys that are present. The mass number is protons and neutrons. So you have 27. So you have 27 protons, and the mass then is made up of 27 protons plus the remainder of whatever that is, 60 minus 27. That's how many neutrons that are present in the nucleus of a cobalt 60 atom. So it is radioactive, so it undergoes this kind of gamma decay. So what happens is this cobalt 60, so this arrow just shows that this element has, or this atom has undergone a reaction, and we get cobalt. So not a lot happens to, so the number of protons and neutrons remains the same, but it gives off energy. And that energy is given off as a gamma ray. So that is gamma rays, and that is an example of gamma rays, cobalt 60. And this tells you how penetrating they are, and they're actually high energy electromagnetic radiation. That's what gamma rays actually are. Okay, so hopefully that makes sense, and thank you for listening.